Okay, we're going to do 9-8. This is where we solve equations with parabolas, with exponentials and logarithmics. Okay, so let's just start with the easy one like we've already talked about. 2 to the x equals 16. In the past, we showed that this needed to be 2 to the x equals 2 to the 4th. Once again, breaking him down, 4 and 4, 2 and 2, 2 and 2. No, it's 2 to the 4th, so x is 4. But we could also have went log base 2 of 16 equals x. And then I go to my machine. Let's go actually back here first, which is once again ln of 16 over ln of 2. So I go 16 ln divided by 2 ln equals 4. And notice we got the same answer, x is 4, either way. Okay, that's a way to do it, but we don't necessarily always work that way when we're going ahead and solving these. Like we brought up before, how do we have something that's solved 3x equals 10? Once again, that's not something I can break down into base 3. So with that being the case, I put it as a logarithm. Notice I just changed. When you get stuck, change. That's the biggest deal. When you get stuck, change. So if you're an exponential, go into log. If you're in log, go to exponential, whatever it might be. But you should change. And then this is, once again, this is the exact answer. But we could do it simplification. And I'm going to use this calculator here. So I'm going to go log, I believe it was 10. Divided by the log of 3. X is 2.09. Notice I could have done that a different way. I could have did ln of 10 divided by ln of 3. And once again, I still get the same result because once again, we just did change the base. So it doesn't matter what equation we use as long as we change the base. Okay, hopefully that's pretty easy so far. The next thing we're going to do is another equation. Here we go. So let's try log base 2 of x minus 1 equals 5. So we're sitting here and we're like, okay, this time we have to be in log. But recall, I want you to remember, this right here always has to be greater than 0. So at the end, we need to check our answer. Okay? Make sure you're always checking your answer. I'm sorry, that was a horrible color, but here we go. So I'm going to go 2 to this power equals x minus 1. Once again, I got stuck. So I went ahead and switched from logarithmic to exponential. 2 to the 5th is something I can hurry and quickly put in. That's 32 equals x minus 1. I go ahead and add the 1. X is 33. Once again, check it. So that's log base 2 of 33 minus 1 is 32. Does that equal 5? 2 to the 5th power, does that equal 32? Sure does. So that's an availability for us to go ahead and keep solving. Okay? Make sure you do check. Checking is important. At the end, check your answers. Sometimes they're going to give you answers that will not work. Let's go ahead and try this next example. Okay? So I have log base 2 of x plus log of x minus 1 equals 1. So whenever I see these, the first thing that I do is I always get it as a common log, not a common log, but one logarithm. I condense it. So once again, that plus right there means multiplication. Okay, so I just condensed it. I could also make this look a little bit different. X squared minus x, don't forget your base, is 1. Okay, so I'm stuck there again. Once again, when you're stuck, switch. So I'm at 2 to the first equals x squared minus x, which is x squared minus x minus 2 equals 0. I'm going to factor. So x is 2 and negative 1. Okay, but notice if I plug him back in right there, that's log base 2 of a negative number. Log base 2 of a negative number will not work, so he is no longer a solution. Let's check 2. Log base 2 of 2, that's okay. 2 minus 1 is 1. Oops, I need to have my base right there. Sorry about that. With those being the case, 1, that'd be just 1. Log 2 of 1 is 0. Log base 2 of 2 is 1. 1 plus 0 is 1. It checks out. You always want to check your answers, especially because as soon as that negative 1 made this guy right here not possible. Even right here it's not possible because I'd have negative 1 minus 1, and that's not possible. So just make sure that you always check your work. Okay? Next. Let's try this one. It's not always going to equal 1, and that's okay. We'll just keep going on. So once again, the thing I see is a plus sign. So once again, I'm going to go ahead and combine these logs as to one common log. Okay, which is log base 5 of x squared plus 4x. Once again, I'm stuck. So I switch. That's 5 to the first equals x squared plus 4x. Get everything to one side. Factor. X equals negative 5 and 1. So make sure I have parentheses around that. As I go ahead and plug it in up here, notice I'm going to plug that negative 5 in for x, and that's log base 5 of negative 5, and that can't happen. So he's not a solution. When I plug 1 in, that's 1 plus 4 is 5, and log base 5 of 1, that's good to go. Happy right there, x is 1. Make sure you check your work. It's essential because sometimes, once again, as we're seeing here, there's values that don't work. Okay? Let's go do our next one. Let's say we have this. Log of x plus 2 minus log of x equals 2. Notice, look, we have one that is not equal to 1. So once again, it's not always going to be that case. So as I'm looking here, once again, I have that minus sign. So when I see a minus sign with a logarithm, as we learned in 9-6, we go ahead and divide. Okay? So right here I'm stuck again. Can't go any further. Remember, if it's not written as a base, it's base 10. So I change to exponential, so I have 10 squared equals x plus 2 over x. That's 100 equals x plus 2 over x. I'm going to go ahead and times x to both sides. Because those cancel out. Subtract the x. Plug in there, it looks good. Plug in there, it looks good. Okay? Pretty simple. Let's try another one. Oh, there's another one equaling 1. This time I want you guys to try it on your own. So I'm want you to push pause right now, give it a shot, and then I'll go through it by yourself. So go ahead and push pause, and then when you're done, push play. Well, welcome back. Hopefully you gave it a shot. The first thing I'm looking at is this minus sign. So once again, a minus sign is a division. If the power is not, if the base isn't there, it's understood to be base 10. So that's 10 to the first because I'm switching because I got stuck again. When you get stuck as a log, you go to exponential. When you get stuck as an exponential, you go to a log. So I have 10 to the first equals x plus 3 over x, which is just 10 equals x plus 3 over x. I'm going to times by x to both sides. Subtract the x. Divide by 9. Once again, 1/3 works for that, and in there. Okay? We're doing really well. Hopefully, those give you a good idea of how to solve. Let me just see how much harder they are on your guys' work. All right. Let's try this one. This is a good problem. So let's say I have e to the 4x equals 5. So this is the same point here. This one right here, though, is I'm in exponential. But once again, I'm stuck. So if you're ever stuck, go to log, or you switch. So therefore, because I'm in exponential, I'm going to go to log. If I was in a log, I go to exponential. So this would be log base e of 5 equals 4x. Another way to write this, remember, is ln of 5, because if it's log base e, it's just ln of 5 equals 4x. Let's go ahead and find the exact answer. So I just divide by 4. X equals ln of 5 over 4. If you wanted to get the approximation, go ahead and go to the calculator. ln, I'm going to clear everything out here. ln of 5, close that parenthesis, divide it by 4. 0.4023. Okay? And that gives you an idea. Just trying to look to see if there's any harder problems really on there than what we just had. Okay, it really doesn't look so. So let's go on to it. There's a couple story problems. Really not too bad. But this is kind of where I started really liking math. We're not getting into it maybe in the 1050 class, but we're going to get into really doubling our money. I don't know if I've told you guys that, but it takes the same time to double 1 cent to 2 cent as $1 million to $2 million. I don't know about you, but I'd rather double a million than 1 penny. And here's kind of where it comes from. So remember, we already had those formulas for compound interest. Notice this is where money usually comes in as compound interest. So once again, this was A equals P, parentheses, 1 plus R over N to the NT. And remember, this is if it's compounding monthly, daily, quarterly. But we also have, if it's compounding continuously, we use PERT. Okay, so those are the two equations that you have. So let's go ahead and start. Okay, so the first one we're going to talk about is, it says this. It says, how long does it take for an investment of $2,000 to double? If we have 5% interest rate, compounding quarterly, okay, so that's the question. So let's go ahead and fill in the things that we know. So I have two, remember, A equals P, parentheses, 1 plus R over N raised to the NT. Okay, so let's figure out what we know. Well, I'm going to start here with my principal. I know it's $2,000. 1 plus, my rate is 5%, so we change that to a decimal. And compounding quarterly means 4 times a year. Okay, so I'm going to put 4 here and 4 up here, but I don't know how long. That's the key question, is how long, so therefore time should be left over. Now, the key question is double. So, if I started with $2,000, my amount will be $4,000. Okay, once again, our goal that we're looking for is to solve for that t. So let's go ahead and do it. Okay, so the first step is to divide by 2,000. Those cancel out, and notice this is 2. And it'll always be a 2 if it's doubling, because doubling means that it'd be twice the amount. If we're talking about tripling, that amount would be 3. Sometimes you hear the half-life of carbon dating and things like that. That amount would be 1/2. So as they start with so much in there, and then by the time they check it, there's so many other grams in it, so it's a half-life. So whatever that is, that's always going to be the same, and that's why, once again, the 1 cent to 2 cents is the same amount of time as it would be our million to 2 million. Okay, it's because of this concept right here that 4,000 divided by 2,000 is double, so that's why it's 2. Okay, so if we'll notice right here, we're stuck again. Okay, so what do we do when we're stuck? Right, we go ahead and switch it. So I'll have log base of 1 plus 0.05 divided by 4, because that's our base, of 2 equals 4t. And then if they ask for the exact answer, it'd be t equals log base 1 plus 0.05 divided by 4 of 2 over 4. And that's actually our time. That's it. So let's plug it in the calculator and see what we got. So I have log. Now remember, we got to change the base. So let's quickly do that here. I'll use yellow right here. So this would be ln of 2 over ln of 1 plus 0.05 divided by 4 all over 4. Okay, so let's go ahead and do so. ln of 2 close divided by ln 1 plus 0.05 divided by 4. Hit enter. That's the top part. Let's go ahead and divide that by 4. And the t here equals 13.49 years. Okay? 13.49 years. So basically 3.5 years and our money will double. I don't know about you, but that's pretty cool. That's pretty cool to think about, that if I got up to 100,000, that after 13 years I'd be at 200,000 with not even doing a thing. We just made $100,000 without even doing anything. We made $2,000 in this example because we started with 2,000 bucks. I mean, free money's free money, and so that's actually a pretty cool idea. Let's do another one. So let's this time think about tripling. So we say tripling. Okay. We're tripling our money. In 3 years. So what is our interest rate? Also know that this is compounding continuously. Okay? So with that being the case, I know A equals PE to the RT. So the thing on this one that's interesting is, notice the only thing they really tell us is 3 years. Okay, so that's going to be our time. But I don't know what R is. I don't really know what P is, and I don't know what A is. But P and A you really don't need to know, because if I even put $3 in there, E to the R, T is 3. Notice our tripling time would be 9. So it doesn't matter what you start with, but no matter what, this number is times by 3, because our first goal is to divide by 3, and I would get 3 equals E to the 3R. Notice this is tripling, hence why it's 3. So on this one, it doesn't matter what you start with, because even if I started with $3 million, $9 million would be with what it is tripling, and when I divide that, it'll always be 3. Okay, so once again, it looks like we're stuck here. So once I'm stuck, I go into a logarithm. So this would be log base E of 3 equals 3R, which is ln of 3 equals 3R. So our interest rate is ln of 3 over 3. That would be our exact interest rate, because once again, as soon as I put it in our calculator, it's an estimate. Let's go ahead and find that. So I have ln of 3 divided by 3. So that's 0.366. So you could say 36.6% would be the amount it takes us to triple our money in 3 years. Okay, that's a pretty cool idea to think about. Okay, the other type of a problem that they could be asking you is just kind of growth or population size or things like that. Okay, so let's say we had continuous growth out in Eagle Mountain, okay, where they're seeing 15% increase every year. Okay, so once again, 15% increase every year. And I don't know about you, but our growth is continuous. It's not every 4 months do all of a sudden people move in, or not every week somebody moves in. It's continuously. It happens all the time. So we would be using, once again, A equals PERT. Okay? Now, sometimes we don't want to put the P. This could also be what we call A sub 0. And just another name for A sub 0 is initial value. Kind of like, if you think about it, if we think about Eagle Mountain, after that first subdivision was built, let's say there was 2,000 people in that neighborhood. E to the 15%, because we had a 15% growth, times time. So then we could say, okay, well, after 10 years, how much population is in Eagle Mountain? And if you guys didn't know, Eagle Mountain kind of popped up when 2000 area. I was like just graduating high school, and I can remember that area just popping up and all those houses and everything. I remember going out to Cedar Fort when I was really young, and just remembering how far it was. But now it's really close. It's not too bad. So let's just plug this in. 2000 E to the 0.15 times by 10. And now, after 10 years, we have 89,063.37 people. So after 10 years, look how much we got. It's quite a bit. Okay, so this just allows us just to find things. Really, that's kind of it for this. The key things that I want you to remember is 1, check your answers. Especially in the story problems, do they make sense? In the logs, remember, log base something of b, but remember, b always has to be greater than 0. That's huge. So make sure you always plug that in to make sure that is happening. Okay, remember, check your answers. Remember, if you get stuck, to switch. And whether that's log to exponential or exponential to log. One or the other. That's really what you're doing. Okay? You also saw that we had these two money formulas. Remember, this is when it's continuously. This is like daily, yearly, monthly, a specific time. Okay, that's happening. Alright guys, that's kind of it. Overall, I think it's a pretty good lesson for you guys to get at. I think you guys can do well at this. Just make sure that you push through it. If you guys need some help, I will be there still on tomorrow, which is Tuesday, and I'll be there also Thursday to come get some help. So kind of jump on this, make sure it's happening. So here's your last assignment while I'm gone. 9-8, 1 through 39, every other. And then I want you to do 45, 47, oops, maybe go back up in there and do 41. Let's try 55. That should be good enough. Once again, on Tuesday of Thanksgiving, week, you guys will have the review. So make sure you're ready, okay? Alright, if you guys have any questions, you could also email me. I don't know how often I'm going to be checking on vacation, but I can give it a shot. also look for others, or you could maybe even go to the math lab that's on Tuesdays or Thursdays. Thanks, guys.